SwayamPrabha. Digital India. Educated India.
Hello everyone, I welcome you all to the last week of the course Automation in Manufacturing. At start of this week, we will be studying the computer-aided manufacturing and the philosophy of computer-aided process planning. The outline of this course is there in front of you. At start of the lecture, we will see the concept of group technology. What is the meaning of CAD-CAM integration? Why it is essential to have the integration of CAD and CAM. We will see the concept of computer-aided process planning. There are various approaches to the CAPP, that is the computer-aided process planning, and these approaches are variant approach and generative approach. So, we will see their concepts and some certain examples. Well, if you start looking at the variety of type of productions which are carrying out in an industry or in an enterprise, we can divide this type of productions into basically three categories or three groups. To understand this, let us take the product variety along the x-axis and production operations volume, the volume of production we will take along the y-axis. When we plot this curve, if the product variety is very less, for example the cement manufacturing company or sugar manufacturing company or any type of process manufacturing company, when the product variety is very less but the volume of the production is tremendously high and there is a continuous production of that commodity or the product, this type of production is called as the mass production. So the characteristic of mass production is product variety is low and production volume is very high. Consider we need a moderate variety of the product, and there may be certain examples such as the tool rooms which are manufacturing dies and molds, or there are certain vendors, those who are supporting the major manufacturers, they are also catering the needs of many industries around. So they are producing the jobs which are having medium product variety and their volume is also moderate, medium volume. So that kind of production type, it is called as the batch type of production. So the batch production has the characteristic that product variety is moderate or medium and production volume is also medium. Production volume is medium Well, if we take the example of a ship, or if you take example of the aeroplane or any bigger or very specialized machine tool which is quite heavy, which we cannot move from one workplace to another workplace. So when the company or enterprise or the factory is focused upon very limited variety. Only one kind of job it is producing, and that is the customized job, which is according to the needs and demands of the customer. That kind of production is called as job shop type of production. The job shop production. So here the product variety is very high. As the customer is demanding, we can generate the products as per the needs. Product variety is very high, and the production volume is very low. Now, if you look at the present manufacturing scenario, you will find two different cases. The first case is rapid changes in customer demands. Rapid changes in customer demands. So that is leading to low product life cycle. So when the product life cycle is low, we cannot manufacture the products in bulk. We cannot manufacture them and just store in the warehouse, because we do not know whether there would be consumption of the entire products that we manufactured. We have to take the decision based upon the demand in the market. So accordingly, when the customer demands are rapidly changing, we have to respond to that. So that's why we are studying this automation in manufacturing course or the mechatronics related course. Well, to cater or to satisfy the changing customer demands, we need to be ready. So for that purpose, we are acquiring, or most of the companies, they are following the batch type of production. They are getting equipped with their factory layout for the batch type of production so that they can cater the customer demands. So in customer demands, they are getting prepared with medium volume range and medium variety range production type. So in general, the today's manufacturing industry, they are following the principles of batch type of production. There is another situation where the batch type of production is important, and that is the tool rooms, or the companies or the enterprises. Their basic product range is having a multiple variety. For example, the garment manufacturing company. In garments, we cannot have a same size garments in bulk. We cannot have same shirt of in lakhs of number of pieces. So there are variety of sizes, variety of colors, variety of types of the styles. So all these attributes are taking into consideration. So I'm just writing for example, there are certain industry such as garment manufacturing or the tool rooms. Tool rooms are generating dies and molds according to the needs, according to the requirement given by the companies. So here as well, there is need to have the batch type of production where we are manufacturing mid volume products, and the variety is also at the mid level. So for these situations, the industry is preferring to go for the batch type of production. The group technology is a philosophy which is taking care of the needs of the batch type of production. It is helping to have the efficient batch type of production. So let us look at the formal definition of the group technology in our coming slides. The group technology, as I mentioned, it is a manufacturing philosophy and which is employed in the industry to improve the productivity. So the entire exercise objective or aim is to improve the productivity, to improve the efficiency of the enterprise. The objective of this course as well, so till now we have seen that 11 weeks. So the technology we are trying to utilize to improve the productivity and to improve the efficiency of the enterprise. So how does the group technology is helping to improve the productivity? So here we are grouping the parts and products which are having similar characteristics. So this philosophy is the manufacturing philosophy, and here we are grouping, as the name itself is suggesting, is grouping the parts or the products with similar characteristics. So what kind of similarity here we are following? We are following the similarity in terms of the geometry, geometrical attributes, and the second is the manufacturing process related. Every product is to be gone through a sequence of certain manufacturing operations. So based upon that sequence, based upon the variety of operations which we are carrying out, we can group the parts together. And afterwards, we are forming the cells. Cells of what? We are forming the cells of dissimilar machines and processes together. So to cater the needs of the part family, to cater the needs of that particular group, we are grouping dissimilar machines or the equipment or manufacturing processes together so that the operations would be easy and the operations would be efficient. Thus, I can formally define the group technology as grouping of parts into families based on their attributes, and these attributes are the geometry attributes and the manufacturing process related attributes. So geometrical classification would be done based upon the size of the product or the part and its shape. Based on size and shape, we are classifying the products or the parts, and that is the geometric classification. As far as the manufacturing classification is concerned, we are classifying the products based upon the type, the sequence, and the number of operations which are needed to manufacturing a product. The type of operation basically is being determined by the method of processing. For example, some products are being manufactured by using casting, some of them are using the sheet metals, some of them are using the welding operations, some of them are wooden products, so where we need to remove the material, that is a machining operation. Then the holding method, what kind of holding method fixtures we are going to utilize during the manufacturing, and the type of tooling being utilized to produce that particular part. So based upon the manufacturing similarity, we are also grouping the products together, and that is the group technology based upon the manufacturing attributes. So when we got a number of products in enterprises, let us consider a automobile manufacturing company, and that automobile manufacturing company is design an automobile, they need to manufacture it. So first the management will analyze that how many parts are to be developed in-house and how many parts can be outsourced, how many parts we can get it done from the vendors. So still the number of parts that to be manufactured in-house would be very large. Then the question comes how to group them together. So fundamentally the very simple process or very basic process is manual visual inspection. A team of experts, a team of engineers, knowledgeable people in the company sit together and they will observe the components, all the components, and based upon the visual inspection, they will take the decision and they group the components together. That is the human intelligence they are applying. The second process, it is the production flow analysis, and we'll be seeing the production flow analysis. And the third is classification and coding. We have to classify the components and then code them, and that coding would be done with the computers, and the computers are storing the data and with the online monitoring, with all sort of instrumentation which we studied in this course, can be utilized to track the products, to guide the products during the operation, to pass the information at variety of places during the operation. So manual visual inspection, production flow analysis, and the classification and coding, here the part families can be formed. So let us look at the first method, that is manual visual inspection method. Basically, the manual visual inspection method, as I mentioned, we are making groups, we are making sets by visually inspecting the physical characteristics of the part. So here we are making the visual inspection and the physical attributes of variety of parts. So to understand the process, let us look at a number of products which are in front of you. Here you can see there are a number of products, and if you just closely observe these products, you will find that some of the products are axis symmetrics. This is the axis, and about this axis we can say that these products are axis symmetric products, and some parts are prismatic products. These are the prismatic products. So I apply my knowledge, I apply my understanding about the parts based upon my knowledge of engineering. I can easily find out that we can group these components into separate teams or the cells, and these are nothing but this. So here we have grouped the parts which are the prismatic parts, and these parts are the axisymmetric parts. So to manufacture these axisymmetric parts, we can suggest that like you can go for the turning operation. The basic operation is the turning operation that need to be carried out to generate these parts. Moreover, in addition to the turning operation, we are going for the finishing operation as well. So turning plus finishing would be useful to generate these parts, and to manufacture these parts, so we can go for the milling operation, or we can go for the shaping operation, which are generating the flat surfaces. In addition to that, we have to go for the finishing operation as well. So in this way, looking at the components, the team will sort out the components, it will group the components based upon their physical shapes, and that will help. But this would be very difficult when number of parts in thousands. Many times there may be confusion, there may be ambiguity. The parts would be looking similar, but they may not be able to manufacture by using the same manufacturing sequence. So in this situation, the team will thoroughly analyze, and based upon that they will take the decision. But when number of parts are more, quite large, then there are limitations on the time. The manual visual inspection is quite accurate, but as far as the time is concerned, it takes a lot of time. So we need to have certain systematic methodology where computers can help us, where the technology can help us to sort out this problem. The next method to form the groups based upon the group technology philosophy is production flow analysis. So in this method, we are working on the manufacturing operations, manufacturing attributes of the products or the parts, and based upon the analysis of the manufacturing attributes and their flow during the manufacturing of this product, we are grouping the products together. Based upon this information, we can generate the cells, we can form the cells, maybe the virtual cells or the physical cells. Cells are nothing but the group of machines, group of dissimilar machines. So let us see how this production flow analysis works. Now the concept is, consider a case where we are having a large number of products. On your screen you can see a modest number, that is 19, but in actual practice the number of parts may be in hundreds or in thousands. There are 19 number of parts and there are a certain number of machine tools which are available in that enterprise or tool room. Now these parts are being manufactured on these machines, they are getting processed on these machines. It's not essential that all parts are to be manufactured on each and every machine, or all the parts are being processed on each and every machine. But more or less the entire group of machines being utilized to generate these parts. Well, the task is now in front of us to group these machines together and the part together so that we can easily handle or manage the operations. We should able to group the parts together so that we can maintain their database, we can follow their production operations very carefully to get the required product quality and the accuracy. And we can manage the number of machine tools which are dissimilar in nature, but by grouping them together we can save the energy, time and resources in material handling. So for that purpose the production flow analysis kind of activity or method is helpful. After carrying out this activity we are getting the matrix which is there in front of you. So let us look at the matrix. Here you can see the part numbers, the order is now being changed. So instead of having 1 to 19, now there is a mix number of parts which are there in a column, and the machine numbers are also, the order of the machine number is also changed. So instead of having the chronological, say from A to K, now we are having the random order of the machines. And if you closely look at now the allocation of the machines to the parts is giving us certain indication. So here you can see, so there are certain clusters which are formed. If you closely look at the allocation, so we can easily detect, we can easily make out the clusters of the allocations. So based upon these clusters we can form the groups. These are the three groups can easily be find out by looking at this particular matrix. So this is nothing but the group technology based upon the production flow analysis. But now the question is that how to carry out this clustering, how to get these kind of clusters. Manually it is fine, but when the number of components are, as I mentioned, are in hundreds and the number of machines are in, they are in tens, the problem is quite complicated. So for that purpose we have to take help of some certain algorithms. These algorithms can be implemented with the help of the computers, and the computers may give us these kind of solutions to us. So let us look at the first algorithm, that is the rank order clustering algorithm. It is a very simple algorithm and it is basically used to form the machine part groups. So let us look at what are the various steps of this algorithm. The first step of the algorithm is assigning the binary weight and computation of decimal weight for each row. So we got various rows of allocations. The default or the first cell or first matrix that we do have, we are assigning the binary weight to the rows, and based upon that we are computing the decimal weight. So we'll be seeing how exactly the binary weights are assigned and how are we computing the decimal weight. Well, the next step is rank the rows in order of decreasing decimal weight values. So after getting the decimal weight values, we have to rank the rows based upon the order of decreasing decimal weight value. And then we have to reorder these rows according to their decimal weight in decreasing weight value. The step number 3 is we have to repeat the step 1 and 2. Now in this case for column, not for rows. So we have to repeat step 1 and 2 for columns, that is our step number 3. And we have to repeat the step 1, 2, 3 unless and until we come to the situation when there is no change in the position of each element in the row and the column. We need to repeat step 1, 2 and 3 continuously till we get a standstill position, no alteration position in the row and column allocations as well. Let us take a case study to understand the rank order clustering algorithm. So here we are considering a tool room, and this tool room is having 5 machines. So based upon the production planning or the process plan of, we found that part number 3 is to be manufactured on machine number A, machine number B and machine number D. Similarly, the matrix is giving the information about the manufacturing of part 2 on B and D, and for 1 it is C and E, so on and so forth for the 4, 5 and 6. So this particular table is giving us the information that the parts are to be manufactured or to be processed on the variety of the machines. And now we need to cluster them. We need to cluster the parts together. We need to cluster the machines together so that the management of the part data would be easy and material handling in a sale would be easier for us. So for that purpose, as the rank order clustering algorithm is saying that we have to assign the binary weights for the rows. So to assign the binary weights for the rows, we have added one more row here, and that is the binary weight row. So here we have added the row, and we are giving the binary weights from the right to left. From right to left, the weights are to be given. So here you notice that the extreme right position is 2 raised to 0, then 2 raised to 1, 2 raised to 2, 2 raised to 3, so on and so forth. Now let us try to find out the decimal equivalent of each and every row. So to find out the decimal equivalent, let us take the first row and find out the cells which are allocated, which are having the value 1. So as we have seen that the machine A is processing only part 3 and part 5. So we have to give the weight, or we have to give the decimal equivalent based upon the binary weight of the location of that machine itself, the 3 and 5, where the machining would be done. For that products the machining would be carried out. As we can notice here that machine A is not processing part 1, it's not processing part 2, it's not processing part 4, and it is not processing part 6 as well. Now let us find out their decimal equivalent. Now to find out the decimal equivalent, what we are doing, we are multiplying this 1 with 2 raised to 1. So here we are getting the product of 1 into 2 raised to 1 plus 1 into 2 raised to 3. So this we are getting the product. This is the product, and this we are just summing. This would be summed, and whatever the value that we are getting, that is the decimal equivalent. So 2 raised to 3 plus 2 raised to 1 is 10. In a similar way, we are carrying out for the row B. So here you notice 2 raised to 4 plus 2 raised to 3 is equal to 24. For C, 2 raised to 5 plus 2 raised to 2 is equal to 36. For row D, 2 raised to 4 plus 2 raised to 3 plus 2 raised to 1 is equal to 26. For last row, that is E, 2 raised to 5 plus 2 raised to 2 plus 2 raised to 0 is equal to 37. Now we got the decimal equivalents for all the rows. What the algorithm is saying, that you get the decimal equivalent and then rank the rows in a decreasing decimal weight equivalent. So looking at these values, we found that the row E is having rank 1, it is having the higher decimal equivalent value than row C, then row D, then row B, and at last the top row is row A. So in this way, the ordering would be here now is E, then C, then D, then B, and then A. So let us rearrange the table by reordering the rows. So here you notice we have rearranged E, C, D, B, A. The part numbers are as it is 1, 2, 3, 4, 5 and 6. Now we have to repeat the procedure which we carried out in step 1 for the columns now. So we carried out that for the rows. Now let us carry out this for the columns. So to carry out it, again we have to get the binary weights to the cells and then compute the decimal equivalent. So let us look at the table once again. Now we got the allocations as you can see on your screen. So 1 1 1 1 here, this 1 1 for the part number 4 on EC. So there is some sort of clustering, some sort of the dynamics is going to happen here. There is rearrangements, and let us see what is the last outcome, what is the outcome of this. So binary weight are arranged. Now you notice that for the column, the binary weights we are allocating from bottom to top. So we are starting from bottom to top. For rows, we started from right to left. For rows, we have done for right to left, and for the columns, we are starting from bottom to top. It is to be noted here. 2 raised to 0, 2 raised to 1, 2 raised to 2, so on and so forth. The binary weights have been given over here. Now we need to repeat the same process that we carried out in step 2. For part number 1, let us compute the decimal equivalent. 2 raised to 4 plus 2 raised to 3, and that is coming 24. For part number 2, we are getting 6. For part number 3, we are getting 7. For part number 4, 24. Part number 5 is 5, and for part number 6 is 16. That is 2 raised to 4 only. So this is giving only the 16 value. Now we need to again follow the same process based upon the binary weights. Now we have to rearrange the columns. So here we are rearranging the columns from left towards the right. So higher decimal equivalent would be taken on the left side and the lower decimal equivalent would be taken on the right side. So 24 is the part number 4 decimal equivalent is 24, that is the part number 1. Here we are having a tie here. So 24, 24 both are similar. So in this case we have to give the precedence towards the part which is on the left side. Then 3, third position is given to the part number 6. Fourth position is for the part number 3. Fifth position is for part number 2, and the sixth position is for the part number 5. So let us rearrange these parts once again. So as we rearrange the parts once again from left to right, now here you can see part 1, 4, 6, 3, 2, 5. 1, 4, 6, 3, 2, 5 have been rearranged based upon the previous step, and the machine numbers E, C, D, B, A are rearranged based upon previous to previous step. Now the algorithm suggests that we need to repeat the step number 1 once again for the rows. So let us repeat the process for the rows. 2 raised to 5 plus 2 raised to 4 plus 2 raised to 3, we are getting 56. For the row C, we are getting 48. For row D, we are getting 7. For the next row, the decimal equivalent is 6. And for the last row, it is 5. So let us give the rank. The rank is 1, 2, 3, 4. The order need not to be changed because the algorithm has given the rank as 1, 2, 3, 4, 5. It is suggesting that there is no need to change the order of the rows here. So once we get this kind of output, then we can say that we have to stop the algorithm and we have to get the clustering. So when we look at the allocations, immediately you can find out that the part number 1, 4, 6 can be clubbed together, and the machines E and C can be clustered together. These two machines can be clustered, they can be clubbed together either virtually or physically. So what is the meaning of virtual clubbing and the physical clubbing, that we will see in the next slide. Similarly, the part number 3 to 5 are to be taken together, and machines D, B, A are to be taken together for the part family operations. So this is the rank order clustering algorithm. There are many such algorithms are available. Now this is very simplified and the basic algorithm. So there may be situation that what to be done when there are multiple number of parts are showing the same decimal equivalent. So what precedence to be given in case of the tie. So for that purpose there are advanced steps are given, advanced solutions are given. Those who are interested, please refer the books related to the ordering, that is a clustering algorithms or computer integrated manufacturing algorithms. So in this way we are grouping the parts, red color parts and the pink circled or marked parts together. The next method of GT based classification is based upon the coding itself. The coding in general refers to the process of assigning symbols to the parts. So coding is the process of providing certain symbols to the parts, and that symbols are nothing but their design attributes, or they are the manufacturing attributes or manufacturing features of that part family. So we have to prepare certain symbol, and that symbol would be easy for the coding. Even that symbols would be helping us to have an efficient computer based program, efficient computer based algorithm as well. If you look at the classification and coding systems, you will find hundreds of the algorithms, hundreds of methods, many number of methods are available in the literature, in practice, in industry. However, all of these classification and coding systems, if we try to group them together, so we can classify them or cluster them into three groups, and these are monocode or hierarchical code system, polycode or attribute code system, and the third one is the hybrid or the mixed code system. Well, let us look at these basic types one by one. In the monocode type of system, the meaning of each character, we are giving certain codes to the product, and the meaning of each character of that code is dependent upon the meaning of its previous character. So consider we are giving a certain code, say C4T1X3. The meaning of 4 is dependent upon the C, the meaning of D is dependent upon 4, so on and so forth. So that is called as the monocode system. Thus, each character is amplifying the information about the previous character. Each character which is in succession, which is coming here, it is amplifying the information, it is revealing the information of its previous character. And basically these type of systems are providing the information in terms of the tree, tree structure. So how this tree structure is being developed, with an example we will see. To understand the monocode or hierarchical code, let us take a spur gear, a component which is there in front of you. Spur gears are generally used for power transmission or for the motion transmission. Now let us find out the monocode for this particular work part. Consider the company is going to manufacture a variety of such spur gears, and for that they have developed a certain methodology which is following the monocode type of the system. So to apply the monocode type of system, the hierarchical code for the spur gear family has been developed, and that is there on your screen. So let us consider any part of that part family, and once the part is come to the decision making team, it may be team comprising of human beings or it may be a computer algorithm. The part has come. Now we have to assign the code for that. So first information would be carried out here, that if the part is rotational, then we are giving the code A. If the part is not rotational, the code is B. Now, as it is mentioned that the next character of the code or the second character of the code is revealing the information of the first character of the code. Now, if the part is rotational, then the next question comes whether it is round with deviation or it is round without deviation. If it is round with deviation or it is round without deviation. If it is with deviation, the code 1 is to be given. If it is not, code 2 is to be given. Similarly, for non-rotational, if it is box-like structure, 1 has to be assigned, and so on and so forth. So you may have variety of additions to the tree, variety of branches to the tree along this direction or along this direction as well. Similarly, after this you may have few more branches based upon the requirement. So for example, I have shown the limited number of branches for this hierarchical code. Now let us consider if the product is round with deviation. The next question would be whether if it is gear we have to assign 1, and if the deviations are non-regular then certainly it is not gear, it is for some other kind of machining feature. So 2 would be assigned if the deviations are completely not regular and the component is not gear. So if the component is gear, then the next question comes whether it is an external gear or it is an internal gear. So if it is internal, give the code A. If it is external, give the code B. If the external gear is chosen, so in our case it is the external gear, again the next questions would be whether it is bevel gear. If it is bevel gear, give 1. If it is spur gear, assign 2, or if it is something else, some other type of gear, then you assign 3. So these are the indication that the branches can be extended. So we can add more branches to this kind of hierarchical tree. For the spur gear purpose, let us solve the coding problem. The part is there in front of you. The part is rotational. So the part is rotational. So we are choosing A. Part is starting with A. So first character is A. As it is A, then we have to ask the next question whether it is round with deviations or if it is round without deviations. So the part is having deviations. So let us have A1. If the part is gear or it is having non-linear deviations, certainly the spur gear is a gear. So one more character, that is 1, has been put. So A11, A11. Then the next question whether it is internal gear or the external gear. So certainly it is the external gear. So we are adding the letter B as a next code. And now the external gear of which type, whether it is bevel gear or the spur gear. So it is the spur gear 2. A11B2 is the mono code for the work part which they are in front of you. So this is just an example. As you are having the complicated parts, the tree would be large, then you have to take help of the computers to take the decision. You have to take help of the CAD softwares to find out the features of the work part, and based on that generate the codes. That code would be put on the work part and then they will be processed inside the factory. In polycode or attribute code type of system, the code symbols are independent of each other. In monocode, we have seen that the code symbols are dependent on each other. The second digit is revealing the information of its previous digit. But in this case, each and every symbol is independent. It is not dependent upon its previous code or the digit. So each digit in its specific location of the code is describing the unique property of the workpiece. That unique property may be the geometric attribute of the work part, or it may be the manufacturing attribute of the work part. So polycodes are finding them quite useful when we want to reveal, when we want to provide the manufacturing information, manufacturing process related information to the user. But the polycodes are having a drawback that the length of the polycode may be excessively long. So when more information or more type of attributes are to be incorporated in the code, then in that case the length of the polycode may be excessively long, and handling such a long codes would be difficult. So let us find out how to define a polycode of a typical product. So to understand the concept, let us take the example of the same spur gear that we have seen for the monocode. A typical chart for the polycode or the attribute code for such facility can be seen on your screen. So here we are making a table, and the table is having a variety of information, and that information is written against the digits. So here you notice the first column is the digit column, and each and every digit is having its specific meaning. The digit 1 is providing, or it is explaining the class of feature as the external shape. 2 is providing the internal shape, the information about the internal shape. 3 is about the number of holes. 4 is the type of hole, so on and so forth, and the gear teeth. And then there are possible values of the digit. So for first, what are the possible values of the digit? If it is cylindrical without deviation, then digit number 1. Cylindrical with deviation, then digit number 2. And the box like is the digit number 3. So when we are giving the value of 2 at first digit, that means the part is cylindrical with deviation. The second digit of the code, we have to assign a number, say 1, 2, 3, 4, 5, 6. If nothing is there in the internal shape, then 1. If the center hole is there, then the possible value of 2. The blind center hole is there, then possible value of 3. So each and every digit is independently giving the information. It's not dependent upon its previous thing. So consider we are having a certain digit here that to be processed for this polycode of the spur gear. So we have seen that the spur gear is cylindrical with deviation. So the code is 2. The spur gear is cylindrical with deviation. So the first digit, the value of first digit we are putting 2. Then we have to choose the possible value for the second digit. So it is none. Whether any feature is there internal, yes, there is a central hole. So this is central hole. The value of the central hole is 2. So second digit is 2. Then we have to examine how many number of holes are there. So there are the holes which are ranging in between 1 to 2. So the spur gear is having only one number of hole. So the third digit is also 2. Then the type of hole. So what kind of hole it is, whether it is an axial hole or it's a cross, or it is a cross axial hole. So this is the axial hole. It is not cross, means not cross to the axis. It is the axial hole. So that the next digit is 1. Now the last digit, that is the gear teeth. What type of the gear teeth are there, whether it is a worm or internal spur or external spur. So certainly it is the external spur. The attribute value is 3. The code for the spur gear as per the polycode or attribute code methodology is 22213. It is 22213. It is more compact than the mono code, and it is very easy to understand the meaning of each and every code because the digits are not dependent on its previous thing. If somebody wants to ask the question that what the meaning of the fifth digit is, a fifth, what type of the gear teeth are, so it is certainly 3 means external spur, it is external spur type of gear. And how many number of holes are there? The third digit is giving the information that the number of holes are in between 1 to 2. So in this way we can retrieve the information from the poly code or the attribute code comparatively easy. But when the number of attributes are more, when more information is to be incorporated, then the length of the code would be excessive. That will consume a lot of space inside the computers, and that will slow down the processing of the data. In reality, in the industry, the most coding systems, they are based upon the hybrid code. So they are getting the benefits, they are utilizing the advantages of the monocode and the polycode methodology, and a hybrid code methodology the industry is using. So in the first digit of the code might be denoting the type of the part. So how the hybridization can be done? The first digit is denoting the type of the part, such as it is a gear. And the next 5 positions might be reserved for the short attribute code that would describe the attribute of the gear. It's a geometric shape and its geometric features basically.